Hey guys, so this is going to be an introduction to different types of angles. We are going to deviate a little bit and kind of do a hybrid combination of the College Board and the other A&M materials that I want to use and kind of supplement and use and implement into the course. So we're going to start this semester off with angles after we spent the first semester doing statistics and some other things. I am currently battling COVID. Hopefully, I'll be back at school Thursday, but I've been out for about 5 days now battling COVID. So, anyway, let's get going. So, when we talk about angles, first of all, let's look at what a ray is, okay? We've talked about rays. Rays goes back to the very beginning of the course when we talked about an object that has an end point, or what we call an initial point, and continues infinitely in one direction. So it's an object consisting of a blank and a blank. And we call this, again, an endpoint, or it's also called an initial point. I'm going to call it an endpoint because that's what your text calls it, but you can actually also call it an initial point. While it is where the ray ends, if you look at it from the other perspective, it is actually technically where the ray begins. So that's hence the argument initial point. But we're going to use endpoint for our course. And it continues infinitely. It goes on forever in one direction. Now, infinitely, that arrow indicates that the ray never stops. It only goes in one direction. And when we look at angles, when we first look at the technical definition of an angle, you can see angles anywhere. And angles can be formed. Technically, angles are formed by segments, they're formed by lines, they're formed by rays. For the basic definition of an angle here, we're going to call it an object consisting of two rays. So this is going to consist of two rays. And those two rays, they have a common endpoint. Now, what are these things called? So when I draw this angle, this right here is my endpoint for my two rays. That is actually called the vertex of the angle. Okay, that's your corner. When I draw the two rays coming off of the vertex, those are called the sides of my angle. So you've got the sides of the angle and you've got the vertices. The vertex, which vertices is plural. So if you look down at the bottom of the page now, you've got the example one, name each of the following. So let's name the sides. Well, the sides, again, we're naming rays. So let's kind of recall what our symbols look like for ray. And remember, the symbols in geometry, your geometric symbols, are pretty much mirror the actual object. You're just making a miniature of each one. So, for example, the sides of this particular angle right here is, if you look at these, I've got this ray and I've got this ray. So I've got ray number one, and that's going to be ray BA. That's the ray that starts at B and goes through A, and I'm going to put a little ray symbol on top of it. My other side is going to be ray BC, and I'm trying to get that to disappear there, ray BC, and that's the ray that starts at B and goes through C. Let me go ahead and advance this. There we go. That'll make it a little bit better so we can see it, and I'll redraw the picture. So those are my two sides, the two rays. What is my vertex? Well, that's this guy, B. B is my vertex. When you name an angle, there are two ways you can name an angle, and the way you name that angle depends on the information that you are provided about that angle. So let's look at the two ways we can name it. The first one is the one letter name. That's what we call the vertex name. The vertex of this angle is B, so I can name this angle B. You can't always do that, though. You can't always just name an angle B. Sometimes you have two angles connected that both have the same vertex, which we'll see later, and you can't just say angle B because then you don't know which angle you're talking about. Then you have the complete name, which uses all three letters. So the vertex is always the middle letter. So no matter what, the B is going to be in the middle. I can call this angle ABC, which basically means angle ABC, or the order doesn't matter. I can flip the C and the A as long, again, as your vertex is in the middle. I can call this angle CBA. Excuse me. CBA. So those are the two ways that you can name an angle. You can use the single with the vertex only, or you can use the three-letter one. We have to use the three-letter one in certain situations, and you'll see those come up later. Going down to example 2, it says here in the diagram, how does the diagram in example 1 differ from the diagram in example 2? So let's look at these two sets of angles. Well, if you look carefully at example 2, I don't have one angle. I actually have 3 angles. And if you look carefully, you can see those 3 angles. Now, most people at first sight say, oh, there's 2 angles there. There's actually 3. Now, all of these angles have the same vertex. So I'm going to put over here that I've got 3 angles, and I'm going to have you name all 3 angles, or I'm going to name them for you since you can't talk to a video. So let's look at the first one. Here's angle number 1. That's the angle that goes from Q to P to R. So my first one is angle QPR. And just in keeping with our pattern, just so you can see the vertex. What else could I also call this angle? I could also call this angle RPQ. Same thing, as long as the P is in the middle. Now that's angle 1. So I'm actually going to label this one angle 1. Now let's look at the next angle we have. We have the angle that goes from R to P to S. So I've got the angle that's RPS. I could also, instead of calling this RPS, I could call it SPR. So that is angle number 2. But there is a third angle here. If you look at the entire angle as a whole, I have angle QPS. So I have angle QPS. And I'm going to actually put the P in the middle there. And you can see I've got 3 angles. I could also call this angle SPQ, and that's this angle right here, the whole thing. So I actually have 3 angles there. So you can see that it's complicated when you get into the angle naming because you have to be able to determine which angle you're talking about. I cannot, in this example, say angle P, because if I say angle P, you don't know if I'm talking about angle 1, angle 2, or the entire angle. It's not specific enough. Once we've actually identified these angles and named them, then we need to realize that an angle separates a plane into 3 distinct parts. So when you draw an angle, just a single angle, and I'm just going to draw a single angle here. I've got my 2 rays, I've got my vertex. When you draw an angle, it separates a plane. Remember, a plane from geometry is a flat surface that extends infinitely in all directions. So if I were to draw a flat plane and put an angle in it, it separates it into 3 distinct parts. And here are the parts that it separates it into. Number 1, the angle itself. The angle itself and every point on that angle. This one, this one, this one, this one, this one, this one, this one. Every point that's actually on the angle, excuse me, including coughing, the vertex, sorry, I'm coughing a lot. The vertex are on the angle. Then we have what's called the interior of the angle. Now you guys know interior, that means inside. So all of the points that are in the interior would be these guys here that are sitting inside the angle. And since we have an interior, there also must be an exterior. And the exterior is all of the other points that are on the outside of the angle. So all of these little red dots here are exterior points to this angle that I've drawn. So that's how we separate an angle. Now, if you look down below, for example, 3 in A and B, it says name a point in the interior of QPS in example 2. So I'm going to scroll here. If you look at example 2, QPS. Let's start identifying angles here. QPS. QPS is the angle that goes from Q to P to S. So what's the vertex of this one? P. Okay, remember the vertex is always in the middle. What point would you say is in the interior of QPS? What is in the interior of this angle right here? And we only have one option, and that is R. So R is the point that is in the interior of QPS. The next question is asking you name a point in the exterior of QPR. So let's go to QPR. QPR is the angle that goes from Q to P to R. So QPR, guys, is this angle now. We're talking about this one, QPR. P is your vertex. So what would be a point that is outside of QPR? Well, if this is QPR right here, the exterior point for you would be S. So I'm going to move this up here, and it would be S. So that's how you name angles, form angles, look at the components, determine whether you're going to use the vertex name or the three-letter name, and determine where in space that angle is sitting or any point relative to it, interior, exterior, or on the angle itself. If I were to actually give you a point like this, and I ask you, where's that point? You would say it is on the angle. It is not in the interior or the exterior. So those are your only three options: on the angle, in the interior, or the exterior.